machines, but with a spark of imagination. Long before humanity touched the stars, we gazed at them. In the 17th century, Johannes Kepler dreamed of sailing to the moon in his novel Somnium, while Jules Verne's 1865 From the Earth to the Moon imagined a cannon-launched capsule. The conceptual genesis, early 20th century. The true birth of spacecraft began in the early 20th century with pioneers like Konstantin Tsiolkovsky, Robert H. Goddard, and Hermann Oberth. Tsiolkovsky, a Russian schoolteacher, penned the rocket equation in 1903, a mathematical prophecy that showed how a vehicle could escape Earth's gravity by expelling mass at high speed. Goddard, an American, took it further, launching the world's first liquid-fueled rocket in 1926, a rickety contraption that flew 41 feet, but proved the principle. Oberth, in Germany, wrote the rocket into planetary space, outlining multi-stage rockets and orbital flight. These men didn't build spacecraft yet. They birthed the ideas that would. The first sparks of life, World War II and the V-2. The real labor pains came during World War II. Wernher von Braun, working under Nazi Germany, designed the V-2 rocket, a weapon, yes, but also the first human-made object to touch space, reaching 189 kilometers in 1944. Its liquid oxygen and alcohol propulsion, gyroscopic guidance, and aerodynamic fins were the embryonic features of every spacecraft to come. After the war, von Braun and his team were spirited to the United States, their knowledge the seed for NASA's future triumphs. The Cold War womb, 1950s, 1960s. The space age dawned on October 4, 1957, when the Soviet Union's Sputnik 1, a polished aluminum sphere with 4 antennas, beeped its way into orbit. Built in a crash program led by Sergei Korolev, it was simple: a battery, a radio transmitter, and a thermal shield. But it was alive, the first true spacecraft. The U.S. answered with Explorer 1 in 1958, a slender tube carrying a Geiger counter to detect cosmic rays. These early crafts were hand-forged, their components tested in wind tunnels and vacuum chambers, their designs iterated on drafting tables. The process was taking shape. A spacecraft's birth required a mission, scientific, military, or exploratory, a design phase, blueprints for structure, propulsion and systems, and construction, welding, wiring, and testing. The Apollo program refined this. The Apollo Command Module, born in 1966, was a conical pod of aluminum and steel, its heat shield ablated from resin, its electronics hand-soldered. It took years. Design began in 1961, with North American Aviation assembling it in Downey, California, under NASA's watchful eye. Each bolt was torqued, each seam X-rayed, because space forgives no mistakes. Maturation and specialization, 1970s, 1990s. By the 1970s, spacecraft grew more complex. The Space Shuttle, first flown in 1981, was a reusable beast, its orbiter crafted from aluminum airframes, tiled with 24,000 silica heat shields, and powered by liquid hydrogen engines. Its birth spanned a decade, from NASA's 1972 contract with Rockwell to its rollout in Palmdale, California. Unlike its predecessors, it was built to return, its wings and landing gear a new chapter in the story. Meanwhile, unmanned probes like Voyager 1 and 2, launched 1977, were born for longevity. Assembled at NASA's Jet Propulsion Laboratory, their gold-anodized aluminum bodies housed plutonium power cells and dish antennas. Every wire was triple-checked, every system redundant, because they'd never come home. Their creation was a ballet of precision, from machining parts to sterilizing them against planetary contamination. Modern births, 2000s, present. Today, spacecraft are born in clean rooms, their stories as varied as their missions. SpaceX's Falcon 9 rocket, first flown in 2010, emerged from Elon Musk's vision of affordability. Its Merlin engines, forged in Hawthorne, California, are 3D printed in part, a nod to modern manufacturing. The Crew Dragon, its companion, is a capsule of carbon composites and touchscreens, assembled with robotic arms and human hands alike. Its birth involves simulation, Digital twins tested in software before a single weld is made. NASA's James Webb Space Telescope, launched in 2021, took 20 years to gestate. Its 18 hexagonal mirrors, beryllium-coated with gold, were polished to nanometer precision in Colorado, while its sun shield, 5 layers of Captain, unfolded like wings in orbit. Its assembly in Redondo Beach, California, was a slow dance of cranes and technicians, each step rehearsed to avoid a billion-dollar miscarriage. Construction materials, aluminum, composites, titanium, are shaped, wired, and tested in labs mimicking space's vacuum, cold, and radiation. Testing. Vibration tables shake it, thermal chambers bake it, and engineers pray it holds. Launch. Strapped to a rocket, it's borne into the void, its umbilical cut as boosters ignite. The legacy. From Sputnik's beep to Webb's gaze, each spacecraft's birth builds on the last. They're forged in fire and math, shaped by history's dreamers and doers. Today, on March 25, 2025, companies like xAI's partners at SpaceX push the cycle faster, birthing ships to colonize Mars. The story isn't over. It's just begun. It seems you're asking for a rare or unusual case or story about a spaceship, something out of the ordinary in the history of space exploration. I'll share a fascinating and lesser-known tale that blends engineering oddity, human drama, and a touch of cosmic mystery. Here's the story of the Salyut 7 rescue mission, one of the strangest episodes in spaceflight history. The ghost ship of Salyut 7. In the early 1980s, the Soviet Union's Salyut 7 space station was a crown jewel of its space program. Launched on April 19, 1982, it was a cylindrical marvel, 16 meters long, clad in aluminum, and packed with scientific gear, telescopes, spectrometers, and a small greenhouse for growing plants in orbit. It orbited Earth at 280 kilometers, a home for cosmonauts studying the stars and their own endurance. By 1985, it had hosted multiple crews, but its story took a bizarre turn when it became a rare case of a dead spaceship brought back to life. The rare case, a silent tomb. On February 11, 1985, Salyut 7 went dark. Ground controllers at Baikonur Cosmodrome noticed its telemetry vanish. No signals, no beeps, just silence. The station's batteries, charged by solar panels, had failed catastrophically due to a short circuit, cutting power to its heaters, radios, and life support systems. Ice began to form inside as temperatures plunged to minus 20 degrees Celsius, minus 4 degrees Fahrenheit. It was a ghost ship, tumbling uncontrolled, a 20-ton relic spinning through the void. The Soviets feared it might crash to Earth, a propaganda disaster during the Cold War, especially with the U.S. space shuttle program flexing its muscles. What made this rare? Space stations don't just die like that. Most failures are gradual,